Hello, namaste everyone. How are you all? Hope all of you are well. Today we are going to discuss valence bond theory from chemical bonding. In the previous video we have completed that how to predict the geometry of the molecules from Vespers theory. Today we are going to discuss about the valence bond theory. First of all, I would like to ask you about the valence bond theory, how this theory was approached and in which year it was approached. So you may have heard the name about Hitler and London. Have you heard? In 1927, this Hitler and London, after getting the knowledge of Pauling had said that two electrons can't have all the four same quantum numbers, or in one orientations both the electrons can't have all the four same quantum numbers, means they both are in a opposite spin. That's why they will not have a same quantum number. So according to this only, I just want to tell you about that how the nuclear attraction force act, and after then we'll run through the valence bond theory. Valence bond theory especially, it is acting upon the valence electrons, how the electrons and nuclear bond is formed. So just suppose about, if I talk about the hydrogen bonding, H2 bonding, you know very well. In the H2 atom, hydrogen, one atomic number, 1s1 electronic configuration, and this hydrogen also 1s1 electronic configuration. Just suppose this is a hydrogen atom, this is its nucleus, this is first electron. Same here, if I talk about, this is the hydrogen atom, and this is the nucleus, and this is the electron. Now question is what? You can see both the hydrogen atoms. In this hydrogen atoms, you have seen this nucleus also. All the positive charge situated at the center of an atom called nucleus. So now just suppose about, this is the nucleus, Na and Nb. And this is the first electron and this is the second electron. Means both the atoms, their nucleus and their. Now if this nuclear repulsion, electron repulsion. Just suppose, I'm talking about, you know very well, is both the nucleus will repel to each other, and this both the electron will also repel to each other. Now what will happen? If they both will repel each other, how bonding is formed? How both the electrons are accommodated in the same orbital? Question is that. You know very well, if I talk about here, just both the electrons will mix and they will form 1s2 configuration. 1s2 configuration means in one box the two electrons are accommodated, right? Both the electrons are accommodated. Both the hydrogen 1s1 will become 1s2, and both the electrons will be accommodated. Now question is how these things happen? How is it possible? Yeah, Pauli has said that all the four quantums number can't be seen. But have you ever thought how these things are possible? How it can be possible? So first of all, if I talk about this electron and this nucleus, there will be attraction force, and this electron and this nucleus, there will be attraction force, right? So now, electron and Na and Eb will have nuclear attraction force, and Nb and Ea will have nuclear attraction force. This both will have nuclear attraction force. And if I talk about Na and Nb and Ea and Eb, they both will have repulsive forces. Why? Because they both are nucleus are the same charges, electron are the same charges. Now question is what? How this bonding is formed? If this force will be greater than this force, nuclear attraction force of the electrons will be greater than the electron repulsion or nuclear repulsion, then only bonding is possible. Otherwise bonding is not possible. So remember, dear student, this nuclear attraction force from the electron is greater than these nuclear and electron repulsive force, then only the bonding is possible. Otherwise bonding is not possible. Remember these things. Otherwise, bonding is not possible. So if you may have heard about these forces, nuclear attraction force, electron force. See, remember, all of us know very well that same charges repel each other, right? Same charge repel each other, and dissimilar charge attract each other, right? These things happen. You know very well how do same charge repel and how do dissimilar charge attract each other. You may have understand this theory from the, I hope, 5th or 4th standard only. The same charge repel each other and dissimilar charge attract each other. So now question is what? Now whatever the nuclear attraction force of this atom, nucleus and this electron, and nucleus and this electron. Now the nucleus and this electron and nucleus and this electron, this nuclear attraction force, electrostatic force you can say, because they both are of the dissimilar charge, electron and nucleus. So both are dissimilar charge. When this dissimilar charge is greater than the similar charges, then only what happens that time? The lowering of energy. The lowering of energy, because here these both energies are lowered. So that time, as this nucleus and the other atoms electron and this nucleus and the other atoms of electrons, the nuclear attraction force or electrostatic force increases. As they increases, then there is a possibility of hydrogen bonding or any atoms. If not, I am talking about only about the hydrogen atom. I have just taken an example of hydrogen. But if I tell you about the other, so now question is what will be the distance? What will be the bond length? What will be the bond enthalpy? How these bonds are possible? You know very well now if they are forming a bond, so they will have some length, bond length. They will remove or attract some energy, bond enthalpy. How many number of bonds, bond order. So these are all the things we are going to discuss in today's topic, that is valence bond theory. So the forces of attraction and repulsion forming during the this hydrogen atom bonding. I hope all of you have understand how this bonding is formed. After then, now question is about, since because of this nuclear attraction forces, the nuclei at this radius, if I talk about the nucleus and this electron, as you have seen here, just suppose here I am drawing in, this is the nucleus and this is the electron. Okay, and this second one nucleus, because of this electron, it will attract by this nucleus and they both the atom will do overlapping. Both the atom will do overlapping. What they both will do? They both will do overlapping. Just suppose this EA is here only. So what they both will do? They both the pure atomic orbitals. Both the pure atomic orbitals will do overlapping. Overlapping means, you know, they both are on each other. That's overlap. As if I talk about, this is my hand and I have covered this my hand. I have overlapped the left hand with my right hand. Overlapped. Similarly, you have seen here both the atoms, few parts are overlapped. Overlapping of orbitals. Right? You know very well how many orbitals are there? S, P, D and F. 4 atomic orbitals are there. S, P, D and F. So you have seen that how these atomic orbitals are overlapped. In this valence bond theory, especially about the covalent bonding, in this especially we'll talk about the S and P. So you know very well S is spheric and P is dumbbell shaped. D double F. Similarly, just we'll talk about these two orbitals. So you know S orbitals is this spherical and P orbital is dumbbell, means here you can see in the P orbitals is just shaped like this. One will be positive lobe and another will be negative. These two are called the lobes, dumbbell. In the dumbbell, one side is positive lobe, another side is negative. You know very well, in the P orbital there are 3 orientations. px, py, pz. So you can see here the positive lobe and negative lobe. So just suppose this is px. If I talk about the py, so here there will be a positive and there will be negative. This is py. And if I talk about the pz, just suppose this is positive and negative pz. So have you understood about the lobes, the shapes of the atomic orbitals, how these atomic orbitals will overlap with each other? These things we are going to today discuss. Especially if I talk about the valence bond theory, why there was a orbitals overlapping and what are the concepts of overlapping. So as already I had informed you about these atoms overlapping, right? Now, actually it was for the hydrogen atom, so it was very easy to know that how this hydrogen atom nucleus and the next hydrogen atom nucleus will attract as the energy will be lowered and there will be a formation of hydrogen bonding. But the things which I have represented, the atomic orbitals overlapping, that thing you must remember, that how do atomic orbitals overlap with each other. How do atomic orbitals overlap with each other? That is the main important thing in this chapter that you must remember about the overlapping. Now question was that why do atomic orbitals overlap? As you have seen in the Lewis dot structure that electrons, both the atoms, electrons, they lower their energy and then they share the mutual sharing of electrons and then they complete their nearest inert gas configuration. Now if I talk about the atomic overlappings of other atoms, it was the hydrogen bonding 1s, so spherical was that. And now how many types of this overlapping, positive overlapping, negative overlapping and zero overlapping is also there. You must remember that what is positive overlapping, what is negative overlapping and what is zero overlapping. So if I talk about positive overlapping, so you know very well in the p orbitals there are three axes, right? Px, Py and Pz. Right? And in S there is a spherical. This is S orbital, this is Py, Px, Py, Pz. In this Px there are two lobes, in Py also two lobes and in Pz also two lobes. So one will be positive, another will be negative. One will be positive, another will be negative. One will be positive, another will be negative. Okay, in the lobes, what is this positive and negative? I am just telling you to understand the concept. In one orientation, maximum how many electrons can be accommodated? 2. In one orientation, maximum number of electrons which can be accommodated is 2. So one will be plus half and another will be minus half, according to the quantum numbers, as we have learned in the structure of atom chapters, that according to quantum number how these electrons are accommodated. Hunds have told first of all the singly electrons will occupy all the orientation and after then the pairing will start, right? So now as you have seen about the positive overlapping, negative overlapping or zero overlapping, how this positive. So when this positive Cartesians of this positive will overlap or positive negative will overlap, then only there is a formations of positive overlapping, negative overlapping and zero overlapping. If I talk about that, just suppose this is S orbitals, S orbital and this P positive orbitals. This is also positive and this P positive orbitals. Okay, so positive overlapping, positive overlapping. Just suppose Px is there. Just suppose this is positive and another Px is there, which is here. This is positive. So positive overlapping means the Cartesians which are on the positive loops. When the positive loops approach to the another positive loops, then there will be positive overlapping. Means it involves the overlaps of the lobes of same sign. It leads to the attractive interaction. Now you will say, sir, here there is one question, that sir, how positive lobe will approach As already I have told you, when there is a nuclear attraction, interactive attractions, then only this type of overlapping is attractive. Because of this attractive interactions, then only the positive overlapping is formed. If I talk about the negative overlappings, it also involves the overlap of lobes, which is the opposite signs, and it leads to the repulsive interactions. Now question you can ask me, sir, this is S overlapping and this is P, right? Px means Px positive. This is also Px and Px. So can it be possible in Py and Py? Yes, my boy. Here positive, here negative. And same if you just talk about this positive, negative. So positive, positive overlapping. So these are the positive overlapping. What are these? These are similarly it can happen into the Pz also. Pz you know very well. Just suppose positive, positive. So these are the positive overlapping. And if I talk about the negative overlapping in the Px, I have already told you there are two symbols, one positive, one negative. So similarly, when the negative overlaps happen. Now if you can ask me, sir, how is it possible that negative overlaps? You can ask me a question here right now that, sir, is it possible negative and negative overlap? Yes, my boy. First of all, the direction or directional properties of bond, when two atoms approach each other to form bonds, their atomic orbitals overlap, and the overlap between the atomic orbitals can be positive, negative, and even it can be zero also. It depends upon the characteristics of the orbital participating to overlap. Which type of orbitals is participating? So if the positive orbitals overlap, then positive lobes overlap of the same sign, then it leads to attractive interactions. If I talk about the negative overlaps, then it involves the overlap of the lobes of opposite signs, and it leads to repulsive interaction. Remember, dear students, here it is a interactions of attractions, interactions, and here what will be there? Negative signs will be repulsion interaction. Interaction, repulsion interaction. Interaction, repulsion interaction. Just suppose these both are, this is also Px and this is also Px. Similarly, Py sidewise. This is also negative, this is also negative. In the Pz, lateral interactions. Suppose this is positive, negative. So when these lobes overlap with each other, then there will be a repulsive interaction, and here attractive interaction. In the positive lobes, attractive interactions, and in the negative lobes, repulsive interaction. And now you can ask me, sir, what's about the zero? Means zero overlapping, positive, negative, and you can talk me about the zero overlap. Zero overlap implies inability of any kind of interaction. Means if I talk about the various arrangement of sp orbitals resulting in the positive, negative and zero overlap, depending upon, especially if I talk about zero overlap now, then just suppose px and s, just suppose px and s. Have you understand that positive interactions, interactive interactions, repulsive interaction, and this zero overlapping means, just suppose this is your P and here is your S. So S orbital and Px orbital. Zero interactions. So how many you have seen about the positive overlapping? In the positive overlapping, what happens? Attractive interactions. Attractive interaction. in the negative overlapping, there will be repulsive interactions, and in the zero overlapping there will be no positive, no, means if I talk about attractive and repulsion, and you can ask me, sir, in zero overlapping there is inability of any kind of, no inability of interactions, means inability, there is no ability of interaction, inability interactions. Okay, so as you have seen the positive overlapping, negative overlapping and zero overlapping. Now this, you can say me, sir, this overlapping concept we have understand in the valence bond theory, especially is about the atomic orbitals, and in these atomic orbitals there are two types of bond, that is sigma and pi bond. So how sigma bond is formed and how pi bond is formed, that is the main important in this whole topic, means valence bond theory whole topic. The main point is about the sigma bond formation and the pi bond formation. Remember dear students, this is a very important topic, sigma bond and pi bond formations. So the valence bond theory deals with the atomic orbitals. It especially leads to covalent bonding. In the covalent bonding, especially about the s orbital and p orbital. Now as you have heard about this atomic orbitals, how do atomic orbitals overlap with each other, positive overlapping, negative overlapping and zero overlapping. After that there are two types of bonding and the nature of covalent bond. Means if I talk about the two types of bonding, the heading you can give in your notebook, two types of bonding and the nature of covalent bonding and nature of covalent bond. First, sigma bonding or sigma bond you can say, and another sigma bond means this bond, sigma bond, and pi bonding. Second is pi bond, means this bond. Okay. Now you can ask me, sir, how these bonds are possible, sigma bond and pi bond, how these bonds are possible. These two types of covalent bonding is there, sigma bond and pi bond. So how is it possible, how sigma bond is formed, how pi bond is formed, you can ask me. The two atomic orbitals, you have seen that they are having the positive overlapping, negative overlapping and the zero overlapping. Now I am discussing about the sigma bond. This type of covalent bond is formed by the axial overlapping. Now you can say me, sir, what is axial overlapping and what is non-axial overlapping? Axial means, you know, axial, what is axial? In the Cartesian point you have heard that in this P orientation, the px, py, pz, px, py, pz. So as I have shown you, the px is in x direction, this is x, okay, py in the y Cartesian, and pz, it is, if I talk about the pz, then it is lateral. So one is this is px, py and pz. In which direction they are? So if I talk about the sigma overlapping or sigma bond, if I talk about, so here I can tell you this type of covalent bond is formed by the axial overlapping of half-filled atomic orbitals. Axial overlapping of half-filled atomic orbitals, and the atomic orbitals overlap along the intermolecular axis and involve end-to-end or head-to-head on overlap. The electrons cloud form as a result of axial overlap is cylindrically symmetrical about the nuclear axis. अब आप पूछ सकते हो कि सर हाउ इज इट पॉसिबल, ये जो आप बता रहे हो सिग्मा बॉन्ड या पाई बॉन्ड, ये पॉसिबल कैसे है? तो सीधा सीधी याद रखना, जो सेम एक्सिस में ओवरलैप करेंगे, when the two atomic overlapping will be in the symmetrical axis, सेम एक्सिस, x x का होगा अगर सेम एक्सिस में, जैसे मान लो s s ऑर्बिटल है, राइट, जैसे s ऑर्बिटल और ये दूसरा s ऑर्बिटल, जस्ट ये भी हमारा s ऑर्बिटल है और ये भी हमारा s ऑर्बिटल है. ओके, so in when these two s orbital will overlap, then they both will be in which axis? Symmetrical axis. So s overlapping will give you the formation of sigma bond. Which bond? S overlapping will give you the formation of sigma bond. Remember. Okay, S overlapping will give you the formation of sigma bond. And if I talk about sp, the S is spherical and p x-axis. Okay, so this electron and this electron both will be overlapping, so there will be a formation of sigma bond. Which bond? Sigma bond. Remember it, I have already informed you, sigma bond is formed by, how is the sigma bond formed? Sigma bond is formed by when the two axial, or you can say the symmetrical axis overlapping. When the covalent bond is formed by the overlapping of atomic orbitals along the same axis, s axis, x axis, s axis, px axis, py और pz, अगर सेम एक्सिस का ओवरलैपिंग होगा तो कौन सा बॉन्ड का फॉर्मेशन होगा? कौन सा बॉन्ड होगा? सिग्मा बॉन्ड का फॉर्मेशन. एंड इफ आई टॉक अबाउट द पाई बॉन्ड, this type of bond is formed by the sidewise or lateral wise overlapping of two half atomic orbitals. या तो sidewise, otherwise lateral. अब क्वेश्चन यहाँ पे ये है कि sidewise और lateral क्या है. तो यहाँ पे जस्ट आपने देखा कि किस तरह से ये सिमेट्रिकल या फिर सेम एक्सिस पर सिग्मा बॉन्ड का फॉर्मेशन होता है. और जो मैंने आपको बताया साइड वाइज का मतलब पी वाई हो गया. देख लो ये है, ये जो एटॉमिक ऑर्बिटल साइड वाइज जो होगा, अदरवाइज जो लेटरल वाइज होगा, साइड वाइज, दिस इज नोन एज साइड वाइज और दिस इज नोन एज लेटरल वाइज. और ये दोनों हो गए सेम एक्सिस पर, सिमेट्रिकल एक्सिस. तो सिग्मा बॉन्ड का फॉर्मेशंस व्हेन the two atomic orbitals overlap in the same direction, that's called sigma overlapping. And when the two atomic orbitals overlap in the sidewise or lateral overlapping, then there will be a formation of pi bond. तो सिग्मा बॉन्ड और पाई बॉन्ड की जानकारी के लिए आप लोगों को बस इतना याद रखना है, जब कोई भी दो एटॉमिक ऑर्बिटल्स सेम एक्सिस में एक दूसरे के साथ ओवरलैप करेंगे, सेम एक्सिस में एक दूसरे के साथ ओवरलैप करेंगे तो सिग्मा बॉन्ड का फॉर्मेशन होगा. साइड वाइज और लेटरल वाइज ओवरलैपिंग करेंगे तो पाई बॉन्ड का फॉर्मेशन होगा. अब यहां से जन्म होता है हमारा हाइब्रिडाइजेशन. ये था हमारा Valence bond theory. Valence bond theory especially deals about the atomic orbitals overlapping, how these atomic orbitals overlap with each other, and how many types of covalent bond or nature of covalent bond, that sigma bond or pi bond. Sigma bond when the two atomic orbitals overlap into the same axis, and when the two atomic orbitals overlap into the sidewise or lateral overlapping, then there will be a formation of pi bond, and in the same axis sigma. अब आ जाएगी जो नेक्स्ट टॉपिक है हमारा, वो है हाइब्रिडाइजेशन. नाम सुना? हैव यू एवर हर्ड अबाउट द हाइब्रिडाइजेशन? हाइब्रिड क्या होता है? हाइब्रिड का नाम सुना होगा आप लोगों ने. हाइब्रिडाइजेशन जो है, हाइब्रिड का जो प्रोसेस होता है उसी को हाइब्रिडाइजेशन कहते हैं. अब क्वेश्चन ये है कि आप लोगों को पता हो गया कि ऑर्बिटल्स क्या है, ऑर्बिटल्स के शेप क्या है, और उस तरह से उनके शेप के बाद जो शेप्स का ओवरलैप हो रहा है, राइट, शेप्स का ओवरलैपिंग हो रहा है, हाइब्रिडाइजेशन. अब देखो, जैसे तुमको पता था कि ये भी s ऑर्बिटल है और ये भी s ऑर्बिटल्स, ये दोनों s ऑर्बिटल्स ने क्या किया? ओवरलैप किया. सो दिस s ऑर्बिटल इज प्योर ऑर्बिटल and this s orbital is also a pure orbital, and when these two atoms orbitals overlap, then there is a formation of impure orbital. Impure orbital. तो ये जो फॉर्मेशन होगा प्योर ऑर्बिटल्स ओवरलैप टू ईच अदर एंड दैट इज द फॉर्मेशन ऑफ इम्प्योर ऑर्बिटल। तो ये ऑर्बिट जो होंगे इस ऑर्बिट का ही नाम होगा हाइब्रिड ऑर्बिट्स। और ये प्रोसेस जो है, अब देखो यहाँ पर तुमने देखा कि when two pure atomic orbitals overlap each other then there is a formation of impure orbitals or hybrid orbital and this process is called hybridization। कोई पूछेगा what is hybridization? When two pure atomic orbitals overlap with each other then there is a formation of impure orbital or hybrid orbital। This process is known as hybridization। जैसे मान लो कि अगर एक हमारा s ऑर्बिटल है और दूसरा हमारा p ऑर्बिटल है, ठीक है, ये s ऑर्बिटल था और ये p ऑर्बिटल था, तो s ऑर्बिटल का एक इलेक्ट्रॉन और p ऑर्बिटल का एक इलेक्ट्रॉन, when this both the atomic orbitals overlap with each other then there will be sp hybridization। sp hybridization ये समझने से पहले आपको पता होना चाहिए कि जैसे ये s ऑर्बिटल है means it is having a 100% s character and this is also having a 100% s character। और just suppose ये जो था हमारा first s, this is 100% and this is also p orbitals का, this is also 100%, but when they both mix with each other this hybrid orbital will have s 50% character and p 50% character। So what you have to understand in this concept, when the two pure atomic orbitals are overlapping then there is a mixture of overlapping, then mixture of orbitals overlapping। तो ये जो mixtures of orbitals overlapping होता है तो इसमें क्या होता है, इसमें क्या होता है, इसमें आपने देखा कि इस दोनों एटॉमिक ऑर्बिटल्स का जो कैरेक्टरिस्टिक्स है वो परसेंटेज अलग हो जाता है। जैसे मान लो कितने तरह के हाइब्रिडाइजेशन होते हैं, तो sp sp2 sp3 dsp2 sp3d d2 sp3 या sp3d2, ठीक है। तो ये जो है इसके अंदर में तुम्हें पता चल गया कि sb50 यहाँ पर p का अलग हो जाएगा, p जो है तुम्हारा 2p ऑर्बिटल, तो ये हमारा टोटल 3 ऑर्बिटल्स है, तो 3 ऑर्बिटल्स में ये 33%, बाकी ये 67% ये दोनों। अब यहाँ पे 4 ऑर्बिटल्स हैं तो p75 s25, यहाँ पे 5 ऑर्बिटल्स है, उसी तरह से जितने भी ऑर्बिटल्स होंगे सबका अलग अलग परसेंटेज, मींस ईच एंड एवरी ऑर्बिटल्स हैव द डिफरेंट परसेंटेज because they are the pure orbitals and these pure orbitals will combine with each other, the strength of this positive or means 50% character or 25% character, जब ये सारे कैरेक्टर मिक्स होते हैं तो इस तरह का हाइब्रिडाइजेशन फॉर्मेशन। तो सबसे पहले आप लोग क्या कीजिए कि हाइब्रिडाइजेशन का डिफाइन लिख लीजिए कि क्या है हाइब्रिडाइजेशन, जैसे मैंने आपको बताया अभी, राइट। हाइब्रिडाइजेशन के क्या क्या साइलेंट फीचर्स हैं वो भी मैं आपको लिख देता हूँ और आप लोग इस चीज को नोटिस कर लीजिए, अपने नोटबुक में लिख लीजिए, फिर टाइप्स ऑफ हाइब्रिडाइजेशंस भी बता देता हूँ। सो फर्स्ट ऑफ ऑल लेट्स राइट द साइलेंट फीचर्स ऑफ हाइब्रिडाइजेशन। So let's discuss first of all about some salient features of hybridizations and what are the important conditions of hybridization. So just take a click of this board, otherwise you can write in this notebook also what are the salient features and what are the conditions for hybridization. So let's start with the salient features. The first salient feature is the number of hybrid orbitals is equal to the number of atomic orbitals that get hybridized. So first of all you should remember the number of atomic orbitals, as for example, as I have told you about sp hybridization, sp2 hybridization, sp3 hybridization. So the number of hybrid orbitals, how many numbers of hybrid orbitals are there. That will only gives us the confirmation about the atomic orbitals are involved in the hybridization. The second point is the hybridized orbitals are always equivalent in energy and shape. Do not understand that S will have more energy, P will have more energy, D will have more energy. Here the hybrid orbitals are always equivalent, in energy and shape. If they will not have equivalent energy and shape, then why they will be involved, why the hybridization process will occur. The third point is the hybrid orbitals are more effective in forming the stable bonds. The hybrid orbitals are more effective in forming the stable bonds and the pure atomic orbital. As the maximum number of pure atomic orbitals will be involved, there will be more stability. More hybridization means sp2, sp3, sp3d. As the maximum numbers of hybrid orbitals are involved in this process hybridization, so there will be more stability. Fourth point, these hybrid orbitals are directed in a space in some preferred direction to have minimum repulsion between the electron pairs, and thus the stable arrangement. Means you know very well. So s orbitals electron is there, p orbital electrons, px, py, pz. So all the three directionals, that px symmetry sidewise or lateral wise, as other electrons are there. So these all the electrons are definitely preferred in any directions. So this must be overlapped when the electron pairs repulsion is minimum. Therefore, the types of hybridization indicates or predicts the geometry of the molecules. Means similarly you will understand the sp orbital means sp hybridization is there. So linear geometry. sp2 angular planar, sp3 tetrahedral. Means suddenly this hybridization will give the confirmation of geometry of the molecules, as we have learned in the Vasper theory how to predict the geometry of the molecules, that it is a linear, triangular planar, after then tetrahedral, after then we have talked about the trigonal bipyramidal, octahedral, square planar. So here the hybridization will give you the confirmation about the geometry and the shape of the molecules. So these were the salient features of hybridization. Now let's discuss about the conditions, important conditions for hybridization. What are the conditions when the hybrid orbitals will form, when the hybridization process will occur? So the orbitals present in the valence shell of the atoms are hybrid. Means which electrons will hybridize? The valence shell electrons which are present in the last cell of the atoms, that valence shell electrons will hybridize. The second is the orbitals taking part in the hybridization must have only a small difference of energy. Don't remember that if there is a s orbital can't overlap with means there must have a small energy difference. If there is a great energy difference, then that atomic orbitals will not overlap, the hybridization process will not occur. If any two atomic orbitals are overlapping or hybridization process is formed, then remember there will be a small energy difference between these atomic orbitals. There will be no large energy difference between these atomic orbitals. Promotions of electron is not essential conditions prior for hybridization. Means it is not necessary that electrons should move from one orbitals to another orbitals. Hybridization is not having this condition that the electrons must promote from one orbitals to another. They are the overlapping hybrid orbitals forming. The main prior condition is for hybridization. It is not for the promotions of electrons from one orbitals to another orbitals. Remember, this promotions of electron is not essential condition prior to hybridization. Last but not the least, it is not necessary that only half-filled orbitals participate in bonding. Yes, this thing we'll discuss in the chapter, means in the standard 12, there is one chapter called coordination geometry. In that coordination geometry, we'll discuss about this thing, that how the half-cell valence electrons are also responsible for hybridization. So that's why I have written here, it is not necessary that only half-filled atomic orbitals participate in hybridization. In some cases means that coordination chemistry, even half-filled orbitals of valence shell or vacant orbitals can also participate in hybridization. This I will discuss in coordination chemistry chapter. I hope these Salient features and the conditions required for hybridization you may have understand. If you have any doubt related to these Salient features or this conditions required for hybridization, then please drop it out into the comment box section. So I have not understand what is hybridization or whatsoever you have not understood. Second thing, in the next video we'll discuss about the types of hybridization. As already I have told you, sp, how, what is the percentage of s orbital, what is the percentage of p orbitals. Similarly, all the main types of hybridization we'll discuss into the next videos, because the time is limited, you know very well. So in the next lecture I will talk about the types of hybridization: sp, sp2, sp3, dsp2, sp3d, after that d2, sp3, sp3d2, all the geometries of the molecules, that how they predict the geometry of the molecules, like sp, how this sp will giving a linear or planar. Each and everything we'll discuss into the next video. That's all for today. I hope all of you have understand the concept of this valence bond theory and the hybridizations. If you have any doubt, then please drop it down into the comment box section. That's all for today. Thank you very much. Stay at home, stay safe. Thank you.